Okay, well, I guess we're live. So, hi everyone, and welcome to this OOP workshop. Thank you all for tuning in. It's a bit different for me as well. I'm used to doing this in front of a full classroom, and I'm not really used to doing this in front of a webcam, but hey, I'll do my best. On the side, I'm sort of checking if everything's going well with the stream, but everything seems to be running. Cool. So yeah, thank you all for tuning in. First, I'm going to start with two notes. One is I'm suffering from a very severe form of man fever, so if I grab for my water during the presentation, please bear with me. Secondly, if you have any questions during the presentation, just ask them in the chat. Maaike is monitoring the chat. If there are small questions, she'll answer them. If there are bigger ones, she'll notify me and update me with the question. Alternatively, if you have any questions after the presentation, we'll make sure that this presentation is available for you guys so that you can leave your questions in the comments. Like, you should be able to comment on this document, and I'll just keep an eye on it and answer as many questions as I can. So today what I mostly want to do is I want to mostly go through the topics that I expect there to be at the exam. I haven't seen the exam, but I've seen a couple of past exams, and based on that, I can make some estimation of what the actual exam will look like. So these are the topics that basically appear or have appeared in the past couple of years. So first, very quickly, we're going to go through the basics, generics. Very quickly, then going to tap into design patterns and streams, then into JavaFX, concurrency. And at the end, I'm not going to go through this, but there will be some old exam questions at the end, which you can do in your free time. So let's start with the basics, just a very quick warm-up. This shouldn't be nothing too new, but hey, maybe you'll get something new out of it. So obviously, oh, by the way, this is also going to be my setup for the presentation, but this is also my setup for basically how I approach making classes, which basically is that I'm always starting with basically the setting up the class, obviously, going to the attributes first. The attributes, basically the variables that belong to a class and that sort of like identify a class. Then into the constructor, the place where you initialize and set those attributes. And then the functions, basically the properties, the things that the class can do. So every slide or during my presentation, I will approach the slides like this, because this is also how I most of the time approach my code whenever I'm coding stuff. So keep that in mind. So basically, when you're creating instances of classes, one thing that we very often notice is that people declare classes, but they don't initialize it. What that means is, if you declare it, so for example, here we had the class person. What happens if you declare it is you say, for example, person P. What then will happen with that class is that P will have the value of null at this moment in time. What you see a lot is the null pointer exception, and the null pointer exception is always caused by an object that is declared but not yet initialized. So before you can actually use the class, you need to initialize it, in this case by saying P is new person with a string and 2 integers. By the way, that was the setup that I had in my constructor, right? The string and the 2 integers. And once you've declared it and once you've initialized it, that's when you can actually use the class. So what would that look like in practice, and how would these variables go? Basically, you say person P, for example, is new person with Sven, 25, which was the age, and 123, which was an ID, some sort of like national identification number. What happens is that those 3 parameters will go into the constructor of the class, which has the format string int, and then the constructor will set those to the attributes. This is also exactly why you can have multiple constructors in Java, because if you have multiple constructors, those constructors will probably have a different layout. So this one has the layout string int. If you make a second one with, for example, just a string and int, and then you create a person and you initialize it with just a string and an int, then Java will automatically look for that constructor, which is exactly why you can have multiple constructors. So into interfaces and inheritance, still a bit part of the basics, but getting a bit more complex here. Let's say that you have an object, or that you have like a group of objects that are similar, but not exactly the same. So let's say that they have objects that have some similar properties. Those are basically the key properties, and those are the ones that you want to define it with, but they're not exactly the same classes. So let's think of like cats and dogs. Cats and dogs are both animals, right? So cats and dogs, like, they both sleep, they both eat, they both drink. It's just that dogs are a little bit better than cats. In that case, they both have the same subtype animal, and basically that's where you can use interfaces and inheritance. Basically, the difference is interfaces are some sort of like main property of what a class can do. They indicate what a class can do, sort of like a functionality. So for example, you could make an interface animal, and a function, you can have a function in there which is basically eat, basically saying everything that is an animal can eat. However, in an interface you can't have attributes. You also can't have function bodies. And sometimes classes are so similar that they do have the same attributes. For example, cats and dogs, they both have names, right? So they can both have an attribute string name, which indicates their name. And eating and sleeping for cats and dogs are quite similar, right? They just go to sleep. So that you can already implement some functions. Whenever you have attributes in these shared classes, or in these similar classes, and whenever you can already implement functions, you go for inheritance, basically with the extends and stuff. Now, this is all quite vague, so let's jump into an example very quickly. This is basically the class person that you saw before, but we're going to do it a little bit differently. We're going to make two concrete classes, namely student and teacher. Both student and arguably teachers are persons. And they both share a couple of things, right? All teachers and students, they have a name, an age, also have a national identification number, and they also can have things like a toString, basically representing basically the ID of the teacher of the student, and they can also work. But that string representation, that identification representation, and the work, that is different for students and for teachers. So what we can do in Java, we can make these abstract methods, basically saying, okay, both students and teachers, they need to have a toString and a work function, but what they do exactly, that will determine in the classes themselves. Now, that's basically what abstract means. So basically saying we need to implement it in the children classes themselves. Now, because these functions are abstract, the entire class needs to be abstract. If you, in a superclass, don't have an abstract function, you don't need to make the entire class abstract. I can't imagine a situation where you don't, but theoretically you don't have to do it like that. Quick example, we can make the class student, which extends person. Now, because we extend person, we can basically call the super. And what does the super mean? The super calls the constructor of person. So whenever you create a student, you could still create a student with a name, an age and an ID. So still the string int format, which is the same as in the person class over here. But now we want to pass on these parameters to the superclass, so to the person class. And by calling super, we push them towards the constructor of person, and that's where you have the attributes, which, by the way, are now protected, because that means that the children classes can access them as well. And that's how it sets the attributes. Because student extends person, we now need to implement the toString and the work method here, which you can see that the toString represents the name of the student plus the age plus the S number, let's say at the university, for example. And with the work, it basically says that the name of the person is studying. So, like I said, with the path of the variables, we now create student S is new student rather than person P, for example, is new student. Then the parameters that we give to the student go into the constructor of the student class. This one calls the constructor of the superclass, so of the person class. And that's where the attributes are now actually set. So now let's look at interfaces. Like I said before, interfaces basically give classes some operation or some skill that they now can do. So for example, let's look at the comparable interface. The comparable interface you've seen in assignment 3, I think it was, with like the shapes, the circles and the rectangles that you had to draw. And basically what you can do with the comparable interface is, let's say that we have a list of person, a list of people. And let's say I give you such a list and I tell you, okay, now sort the list. If I give you a list of integers, it's fairly straightforward how you are going to sort it, right? Most of the time you sort it in ascending order. But if I give you a list of persons, it's not very clear how you're going to sort it. That's what the comparable interface is for. The comparable interface basically gives some sort of default method on how to sort a list or how to sort a specific object. So in this case, you can see the method compare_to, which is initialized because of the comparable interface, and in there we say integer.compare age and o.age. So basically we compare the other person, so the person that's given in here, O, to this class itself. By the way, what you need to do is always you need to return -1, 0, or 1, depending on which one is larger than the other, or if they're equal, and that's exactly what the integer.compare does. It's a default method that's built into Java. So most important takeaway here is that if you implement an interface, then you get a method that you need to implement. So, for example, we can create a list of person here. We add 2 students and a teacher, Sven, Bob, and Peter. We're gonna print them, so at first they'll just be printed in the order that they're put in the list. Then we're gonna sort them, because now we added the comparable interface that made it sort by age, and now you can see that they're sorted by age. So first Bob, then Sven, then Peter. And this is quite a good transition to Lambda expressions, because Lambda expressions are often sort of like replacements for interfaces. But before that, let's take a step back. So let's say that, okay, so we created this default way of sorting persons, right? We're saying, okay, if we have a couple of persons, we're sorting them by age. But what if we want to sort them by a different manner? So let's say that we want to sort them based on ID. You can only give them one comparable interface, aka one default method of sorting. But what we can also do is that this arrays.sort method that you can see in the bottom left, it takes a second parameter, which is a comparator, which basically is a custom way of sorting something. So we have this interface comparator, and comparator can be given as a second parameter to a sort method, like I said, to give like a custom manner of sorting. What you'll see then is that the class that you make implement comparator gets a compare method with 2 persons this time. Why 2 persons? Well, 2 persons because it's not in the class person itself, so it needs to get both person. And now you can say, for example, return integer.compare o1.getID and o2.getID, basically saying, okay, we want to sort based on ID this time. And what we can now do is in the sort method, we can pass in the comparator, basically saying, okay, now I want you to sort based on ID. But what you see now is that we make an entirely separate class to basically implement this comparator, which is, you know, it works, but it's quite ugly. What you could also do is you could also just define it locally. So in the arrays.sort method, we're creating a new comparator locally, and then you get that compare method in the arrays.sort. However, if you have a bunch of code and all of a sudden you have like 6 lines instead of 1 because you just want to have a custom sort way, that's quite a lot of code, and again, quite ugly. And that's where Lambda expressions come in. With Lambda expressions, you can basically reduce all that code to a single line. So what I see a lot what I see quite often is that people basically think of Lambda expressions as these magic things that add like a lot of functionality. They really don't. All they are is basically a different way of writing your code, basically a way of compressing your code a little bit. So if you compare it to the anonymous class, what it's called, that we saw before, on the right hand side you can see that the compare method has two input variables, two input parameters essentially, person01, person02, and then the return statement integer.compare o1.getID, o2.getID. If you look at the Lambda expression, we can see this exact same setup. So we have two input variables, o1 and o2, and one return statement being the integer.compare. Two things that you can notice here. The first one being with o1 and o2, it doesn't state the type on the left hand side, right? It doesn't say that it's person. Well, it doesn't have to, because peeps, the list, is already of the type person. And Java is smart enough to recognize that if the list is of type person, then o1 and o2, the input variables, are of type person as well. By the way, you can name these, you can name these input parameters whatever you want. You can name the p1, p2, you can give them fruit names, cookie, banana, it doesn't really matter. Second thing that you might notice is that on the right hand side we explicitly say return integer.compare. But on the left hand side we don't explicitly say the return. That's because Lambda expressions assume that if you don't add function brackets to the Lambda expression, that you want to return whatever's in there. If we added function brackets in there, then you can add a couple more lines of code, but then you need to explicitly say return integer.compare. Okay, into iterators. It's a bit of a weird transition, but we'll get to an exam question where we need all these things. Iterators are basically a method to iterate through lists. So you've all seen for loops, you've probably seen enhanced for loops, but what if you want to iterate through a list and you want to modify the list while you're iterating through it? Let's say you want to evaluate each element in the list, and based on that evaluation you might want to remove it. Well, if you work with a for loop or with an enhanced for loop, removing stuff from a list, this is always, by the way, an array list or a linked list. Whenever you want to remove stuff from a list, you get problem with indexes, right? Because the entire list shifts and your for loop all of a sudden doesn't make sense anymore. That's where iterators come in. So these are the functions that you need in an iterator, but I can explain them like this. I think it's easier if I explain them in an example. Let's say we have another list of person, and what we want to do is we want to remove all the people who are younger than 23, right? So that means that Sven and Peter are staying, but that Bob needs to be removed from the list. So first we create a list, we add the students to the list. So if we would print the list on the right hand side, you can see that it prints all three of us. But now we want to create an iterator to remove all the people younger than 23. So what we can do is we can say iterator of person. Beware, the type of the iterator needs to be the same of the type of the list that you're iterating through. And then you can say is peeps, which is the name of the list, dot iterator. That gives me an iterator that I can use to iterate through the list. And I see that there's a question.
Why do you write arrays.asList here?
This is just a very quick way of adding some default methods or default objects to a list. What you could also do is basically just say peeps.add new student Sven, peeps.add new student Bob, peeps.add new teacher Peter. This is just a quicker way to add a couple of elements to a list already. So anyway, we created the iterator, and what we can now do is we can say while iter.hasNext, or in other words, while there are still elements left to explore, we grab basically the next element in the list by saying person p is iter.next. It grabs it and then removes it from the queue of people that we want to explore, and then we can evaluate it. So for example, we can say if p.getAge lower than 23, we say iter.remove, and by saying iter.remove, it removes it from the original list without messing up the indexes. And then if we system out it, you can see on the right hand side that it's actually removed. Okay, on to the next topic, being generics. Always quite a difficult one, but I hope that I can make it a bit more clear also with the exam question that we're going through later. So generally, you can use generics in two different types, and generics always mean that we are going to need some variable in a class or function, but we don't know what type that variable will be of yet. So an example is a linked list, right? A list can be of any type. It can be of type string, it can be of type integer, it can be of type boolean, it can be of type person. We don't know beforehand, we just know that it will be of some type. So a list is a perfect example of a generic class. So we can essentially make two things. We can make an entirely generic class, or we can make just a generic function. Now what do they look like? Let's say that we have a generic function. So again, we know that there will be some type in this function, we just don't know what that type will be. So we indicate that the function will be generic by saying public and then in diamond brackets t. T is going to be some type. We don't know what type yet. We can replace t by anything, by the way. We can call it r, s, give it any name. Then we're saying t, and basically this t means the return type of this function, right? So for example, a string, like a toString method is of type string. This method is of type t. So t is now an existing type because we basically initialized it or declared it over here. So this function is going to return a type t, and then, for example, in this case, we're calling it head of list. So basically what this function is going to do, it's going to return the first element of a list. So there can be any list as an input type, so a list of strings, person, doesn't matter. And what this function does is it grabs the first element of that list. We can now say t head, because this is a generic function, so Java now knows that t exists in this span. And then we can say t head is input.get0, basically grab the first element, and then we can return the head. So how would that work? For example, let's say on the right hand side that we create a list of integers. We're using the arrays.s list again to just quickly add some values. We're adding 1, 2, 3, 4, 5 to the list, and then if we print the head of list function of that list, so basically the function that I just created, the output would be 1. Now let's say that we have a generic class. Whenever you create a generic class, rather than at the beginning of a function, you basically stated at the beginning of a class that the entire class will be generic. So here we're basically creating the class pair, saying x and y are going to be some types in this class. We don't know what types yet, but we know that there will be some type. You've probably seen this before with the map function. I think it was like basically the hash map, where you can basically assign a string to a boolean. I think that was one of the assignments where you had to evaluate some stuff. So a map is always also an example of a generic class with two input types, two generic types. Because x and y are now defined at the top, we know that they're going to be some type, or we know that we can use them in the class itself. So we can say private x, because x is now an existing type. Same for y, and we can just use them in the class as if they're some existing type, as if they're strings, as if they're integers. And if we were to create an instance of this class now, we can say pair of string and integer. Note that now we have to explicitly say that in pair it will be a string and an integer. And we can add two values to it, and at the end you can see that I'm adding hi and 1 to 3 as a string and an integer. One thing to note, by the way, is that if you look at the generic function, you don't have to explicitly say of what type the generic is in a function. And why? Because it basically extracts that type from the input that you're giving. So when I'm calling head of list, I'm giving a list to that function. and that list is of the type integer, and therefore the function will recognize that, that the return element is an integer. So, given all this, let's jump very quickly into an old exam question. So, this is a question from the exam from 2 years ago. I think this is also available on Brightspace. The reason why I want to go through this question is not just to show how what I showed you before basically can get you to the answer, but I also want to show you very quickly how I would approach such a question in answering it based on how we are grading the exam. And to give you some insight on that, basically we are assuming that you get full points for the question, or for your answer, and then we're deducting points for little parts that you're missing. So for example, in this case we say that you have the interface predicate, and that's something that just exists in Java. And then the assignment for you is define a class filter with a static generic method filter that gets both a predicate and a list of elements as arguments, and the elements of the list that do not match the given predicate are removed from the list. These elements are collected in a list returned by filter, and when the input list is an array list, the result should be an array list, and otherwise the result should be a linked list. Use an iterator in your solution. So, for example, the way that we would grade this assignment is that if you, for example, don't make the method static, points deducted. If you don't make it generic, points deducted. If you don't use an iterator, points deducted. So what's very easy for you to do is, if you know how to make a generic function, just write down the frame of a generic function and you already get some points. If you know how to create an iterator, but you don't know how to do the rest of the assignment, just write down how you create an iterator and you'll already get some points. So I just wanted to give you that insight very quickly. That being said, what I always do and what I always recommend you doing whenever you're tackling an exam question like this is to make notes, right? You're using a computer, you have an IDE, so you have as much room to type as you want. So for example, I would write down some sort of like step-by-step way to approach this question. First of all, create skeleton for the method, right? We know that we need to make a generic method, so we can create a generic function already. I see a question, yes?
Do you deduct points for things that work but are ugly? Because I didn't think so, because I wrote a really ugly method on my exam that was like full points.
Not necessarily. I think last year even, we already gave points for things that were pretty much pseudocode, right? Things that would not compile. So let's say that at the day, like you're very nervous, you don't know how to write system.out.print, and you just write print, you know, that's fine, right? We get the intention, and the fact that you don't remember the syntax at that moment in time, we'll forgive you. So, you know, things like that don't really matter. That's why I would also stress, don't focus on your program actually compiling at the exam. Just make sure that you get as many points, like as many bullet points that you see in the question into your solution as possible, because that's how you score your points. So that's why I would also recommend starting with a step-by-step plan, because what that basically forces you to do is basically write some pseudocode already, and even if you don't know the exact syntax, then you already get points for that. Yes?
Last year we didn't use an IDE, so the question is, was there more lenient last year, and will it be then the same this year when they can use an IDE?
I find that a very hard question because I don't make the exams, but that being said, the teachers don't want to fail you, right? The teachers want you all to pass. So the teachers generally are quite lenient, and that's all that I can say. So it I don't know what the grading will be like. I mean, I'll learn on Monday when we're gonna grade it. But yeah, I think they'll be lenient. I think that they won't make a fuss about it too much. And otherwise, I think there are always TAs who are standing up for the students, and the TAs want to be lenient as well, right? We want you guys to pass as well, just as much as you want to pass. So again, like if there are small things. So okay, for example, let's look at let's look at locks. Like, let's say that you create, I used this example last year, so that's why it popped into my head, but let's say that you need to create a lock for concurrency, and you know that it's called something like a re-entrant lock, but you don't know what it's called exactly. Now, if you write something like relock or lock is new lock, then it's fine. I mean, if you start messing around and you write down lock is new Revenge of the Sith lock, that's when you're stretching it a little bit, and we're probably not going to be as lenient, but just make a serious attempt. And if we can see that you actually tried, but that the correct syntax just didn't pop into your head at the right moment, then we'll most likely be very lenient with it. So I hope that answered your question. So anyway, back to the step-by-step plan. So what I would say, step 1, create a skeleton for the method. Step 2, in the question we derived that we need to make an output list, and basically in that list put all the elements that do not match the given predicate. Let's take a step back, by the way. What does this mean exactly? Let's say that we have a list of integers. The predicate could be, for example, integer must be larger than 5. So what that would mean is that if the elements do not match the given predicate, aka if the integers are not larger than 5, they'll be removed from the original list and put in the new list that is returned by this function. So to make sure that that's clear. I saw another question.
People are sending hearts.
Oh, thank you for the hearts. So we need to create an output list that's either a linked list or an array list, depending on the input type list. And this is a perfect example of where we probably be lenient with your notation, and I'll show you that when I show the solution. Step 3 is I would create an iterator. Step 4, test if the predicate, if basically testing, or if the predicate returns true or false, if the predicate test is true or false. If it is, if it is false, remove it from the input and put it in the output list. Yes?
What is the difference between an array list and a linked list again?
In short, I don't know which one is which, but one is quicker to write elements to, and the other one is quicker to remove elements from. I think that's basically the difference, but you don't need the difference you don't need to know the difference for yourself. If we don't mention which one you should use, you can use either one. It doesn't really matter. So, back to actually implementing this question. So the first step that I said was start with the skeleton. We know that it's a generic function, so we have to start with that t again. Right, that t in diamond brackets. We also know that it's static, so we need to make sure that we add public static at the beginning. So public static t, that already is going to give you some points. We know that the return type is going to be some list of type t as well, and they said that we needed to call it filter, so that's the first part. Then the two elements that we pass in, basically it says that they are a predicate and a list of elements. As you can see over here is that the predicate is a generic interface as well, so we need to give it a type. Now, let's say that you pass in a list of integers, then the predicate needs to be of the type integer as well, because it's gonna check for that same type. So they're all using that same type t. And then at the end you'll see list of t input, and that final list, that's where this function will derive its generic type from. So if that list is of type integer, then it will assume that every t that you see over here is of the type integer. Next step is we create a list, and it's either an array list or a linked list, depending on the type on the input list. So this is a part where we would be very lenient. So for example, if you would write down if input is array list, or if input get class is array list, like something that we know that you know that or okay, let's retry that. Something that we know that you actually tried it and that you had the right intention of checking that it's an array list, then you already get points for that. Yes, question?
Do we have to implement the interface in the class filter to be able to use the predicate?
No, because the predicate, so basically, okay, you know what, I'm going to continue with the with answering the next question, and then I think it will be more clear why. Actually, I can answer it, I can still answer it right now. Basically, you need to pass in a predicate, right? So you need to create a predicate somewhere, and then you need to give it to filter whenever you're using it. But the class filter doesn't have to be implementing predicate, as long as you input some type or some predicate as the first argument in the filter method. So we established that we are creating an array list or a linked list. Next thing is we have to use an iterator. So we create an iterator, and we also know that the iterator has the iter.hasNext and the iter.next method. So basically this while loop is pretty much the same for every iterator that you're using. The one difference is that now we say t, like the element is of type t. That type t depends on what iterator or what type of list that you're iterating through. And then the final part, if an element that does not match the given predicate, add it to the output list, remove it from the input list. Okay, so basically, well, I had 5 steps here. I merged 2 steps together here, but basically I went step by step, implementing 1 step at a time that I have written down here, and that gets me to this solution at the end. Next question of this exam was define a method added to filter that uses filter to print all odd numbers from the list containing the numbers 1, 2, 3, 4, 5, and use a lambda expression to specify the predicate. So the first part is, okay, now we need to realize what does our predicate need to be. So it needs to use filter to print all odd numbers from a list containing the numbers 1, 2, 3, 4, 5. That means that the predicate needs to check whether the numbers are even or not, right? Because the numbers that are not even, aka the numbers that are odd, are then removed from the list and basically put in our output list. So basically we know that we have this, so list of integers input is new linked list. Then I'm using the input.addAll arrays.asList. If you want to add them one by one, that's fine as well. You don't need to know this method. So if you want to say input.add1, input.add2, that's fine. Then we know that we have some Java code. We know that we need to do the lambda expression, and then we know that we want to print the output. Again, just write down this if you don't know how to do the lambda expression, because you'll already score points for this. But now let's look back at how we did the lambda expressions. So now we have an interface, a generic interface predicate with a Boolean test. That's actually quite similar to the interface that we saw before with the comparator, where we also had a generic interface with a method compare. I'll get to the question in a couple seconds. So in that instance, basically the compare method returned an integer.compare given 2 inputs O1 and O2. So basically the setup for our lambda expression here is quite similar. So this test method that you see over here is essentially the same format as the comparator on the right hand side. See, so on the right hand side here you have an O1, O2, and you return an integer.compare. Here you have an input I, and you're returning I modulo 2 is equal to 0, basically checking is it even. So now we can change this. We have the input I, the return statement, I modulo 2 is 0, and we can replace that by a lambda expression here. Yes, for the question.
The question was, in the filter method, does it make a difference to also remove the elements from the input list during the iterator loop?
Yes, it does make sense. And the reason for that is so the question was if it makes sense to remove it during the iterator.
Does it make a difference to also remove the elements from the input list during the iterator loop?
Oh, like for the end result or what? I mean, in the end, like the method is called filter, right? So you do want to filter the list, you know, like by the name, I would judge that that's basically the whole idea behind this method. Does it make a difference? Not really. Because and especially because you're using iterators, it really doesn't affect how you handle it. Like like iterators handle all the indexes. So in that sense, it doesn't make a difference. Does it make a difference for the functionality? I mean, it's just what the teacher specified here, so that's the reason why I'm doing it. So yeah, anyway, this would be the anonymous class method. This would be the Lambda expression method, and that corresponds again to the example that we saw earlier. On to the next part, design patterns. This might be a bit new for you. I don't know how much they handled this in the lectures this year. I'm also not going to go through it too much, but I'll explain my thoughts on it. But before that, I'll answer a question.
Can you also create a string first and after that the dot filter?
Yes, you could. But again, the teachers explicitly mentioned that you had to use an iterator in your solution. So yes, absolutely, that would be a very valid method. But the teachers, like I said, explicitly said that you needed to use an iterator. So that's what we're doing. Anyway, into the design patterns. Design patterns are a tricky one. So one of the design patterns you've seen, namely the visitor pattern, was the exercise with the generics and with the expressions, I think it was. Design patterns are essentially just a way to structure your code. Just like Lambda expressions, they don't add any special functionality to your code. The reason why I added this is because the past couple of years, design patterns always played a very significant role at the exam. We always used to see the strategy pattern, the decorated pattern, or the visitor pattern. But that kind of changed recently. So what I would just say for this one is I linked videos, like explanation videos for the visitor pattern, the decorated pattern, and the strategy pattern, and I linked it to a guy who can explain it way better than I can. So what I would just do is try to watch those. I think they're like 5 to 10 minutes long each. Make sure that you understand them, and that's all you can really do for the design patterns. So for the design patterns, might be at the exam, I don't know for sure. I just wanted to include it in here just so you are aware that it exists. Yeah, they're very, like, I think it's quite likely for the visitor pattern to be at the exam, but, you know, what do I know? Next part, streams. Also for this part, I want to mostly just point out that it exists and what the most important things are, but I'm not going to go into it too much. Yes?
Where are the links?
So the links are actually on these buttons, like these things that you can see here are buttons. So again, I'll make sure that this presentation will be online and available for you, so you can look at it. And you'll find like a lot of links in here. And if you just need, and if you have any questions, again, just add a comment to this document and I'll make sure to answer it. So on to the streams. Again, I'm not going to go through it too much, but I am going to mention that there'll probably be in a very light form at the exam, and what you mostly just need to know, I think, are these methods. So the map, produce, the sum, the filter, the sorted, and the collect. And what I would just say is there was one assignment based on streams. If you are able to do like the first 5 or 6 methods in that assignment, I think you already know enough for streams. I don't think we'll make it too complex. The one thing that I'll say with streams is that you need to know that they are Lambda expressions as well. But yeah, just make sure that you know in principle how streams work, and then you're already good to go. On to the most fun part, the Java FX. So for the Java FX, explicitly for the Java FX, I would recommend you not, because you're using an IDE, I would recommend you not to focus on creating a functional Java FX application. mainly because I know how frustrating it can be, how time consuming it will be, and it's just a waste of time, honestly. So what I would do is tag, most of the time the JavaFX question exists out of a couple of sub-questions. Make sure that you answer those sub-questions, make sure that you do like the step-by-step, basically writing the pseudocode first and then implementing that. But don't focus too much on getting it functional, because most of the time, like, we don't compile it when we're grading the exam. So we're not going to test if it actually shows up and if it works properly. That being said, the things that are most important for JavaFX and the thing that you probably will get questioned about if you will get a question, definitely properties. So the ability to bind variables to each other, meaning that if one variable changes, the other variable changes. The timeline, which basically is a piece of code or like a function that executes another piece of code at a certain interval. For example, we used it at the snake to make sure that the snake moves every, I think it was like 200 milliseconds. Lastly, event handlers, essentially saying what happens if you click the mouse or press a keyboard button. To get into some examples for that, let's say that we want to create a text field and a rectangle, and the value in the text field indicates the height of the rectangle. So first of all, we need to bind the text field to the input property, to the double property input. Basically, this means that if the value in the text property changes, then the value of the input property changes as well. So if I enter the number 5 in it, then the double property value will change to 5 as well. In this particular feature, I don't know why I added 10 to the input, but we're essentially saying that the height double property is binded to the input double property plus 10. So if we have 7 in the text field, then the input double property will change to 7 as well, and then the height double property will change to 17, because 7 plus 10. And then we can bind the height of the rectangle to the double property of the height. So again, just make sure that you know how the binding works. I think that's the most important part for the JavaFX. Yes?
When do you have to use .getChildren?
Right, I just totally splashed water in my eye and try to play it off cool. You need to use getChildren basically, and I think this is more detail. Okay, let's take a step back. What happens most of the time with a JavaFX question is that the teachers will provide you with essentially the framework of the application. So they'll provide you with all the panes, with like a grid layout, or like the grid pane, or the V box, or the H box. They'll provide you with those layout things, and you just need to add your components to those existing things. So for example, they give you an H box that says text fields, and then if you create a text field, you need to just add it to basically that H box. So you don't really need to know all the panes, all those specific things to basically create the layout. Those are given to you, and that's why I pointed out that these three things are the most important ones for you. Now, when you do need to use children, just to still answer the question, JavaFX is built up in sort of some like a tree structure. So you start with like the main window, and then you go to its children, which can be like a big square, which can be like a grid pane, and like an H box, which can be like a box where you have some text fields, for example. So if you want to add something to that main display, you need to call the getChildren on that main display. Then you'll get the list of children, because all the children are always stored in a list. And you can say, so layout.getChildren.add, right? Because with add, you can add stuff to the list. And that's why you need to call the children method, because it gives you the list of elements that are in a specific layout. Yes?
Couple more questions. What is a number string converter?
Okay, number string converter is an input field or a text field is always a string. Even if I write an integer or a double in there, Java still treats it as a string. So the number string converter basically converts it from a string to a double. Also, whenever you're using binding, the thing that is listening to the other thing is always at the beginning. So if you see height.bind input, it means that height is dependent on input. However, this is not always the case. So for example, with the input field, the text field, you see that like input is listening to the text field, yet the text field is at the beginning. The reason for that is because we need to convert it from a string to a double. And for some reason, you cannot do that in the regular bind method. So you can only do that in the bind bidirectional. So that's why we're using the bind bidirectional. A bit counterintuitive, but this is one of those things that I would just advise you to just remember.
Wait, did you just explain the difference between bind bidirectional and bind?
Yeah.
Oh, cool, because that was another question.
Okay. So again, well, to do that a bit more explicitly, with bind, you only listen to one side. So for example, height.bind input basically means that height changes if input changes, but input doesn't change if height changes. For bind bidirectional, the change goes both ways. So for example, let's say that we have two text fields and we make them bind bidirectional. If you change the value in one text field, the other text field changes. If you change the value in the other text field, the first text field changes. So that's essentially the difference. Were there more questions?
Yeah. With the practice exams and the methods on paper did not copy paste well into the NetBeans, will it be like this in the exam, or will they give a zip or something? Do you know?
I don't.
Okay, same.
So yeah, that's also why I mentioned just make sure that you add the lines of code that you need to add and don't focus on making it actually function or do something, because they generally don't ask you to change existing code. They just ask you to add stuff to the existing code. Again, so just make sure that the things that you add, or just focus on the things that you need to add, and don't focus on making the entire thing work.
Okay, and then one more question. Are listeners also important?
I guess so. Yeah, I think so. I think listeners, I didn't include them here. I'll add a slide on listeners with like a Boolean example, because listeners are most of the time used with, for example, Booleans or double properties. I'll add a slide on that in here because I can try to explain it without code, but that just doesn't work. So I'll make sure to add a slide in here with some more explanation on how listeners work. Onto the timeline. Like I said, the timeline is a piece of Java code, a function that basically executes a piece of code on a certain interval. So for example, we want to call some function, which you can see like somewhere on the right hand side of your screen. We want to call that every 500 milliseconds. The timeline is pretty much, you need to know what it does. So if you know, okay, every 500 milliseconds it will call some function, that's all that you need to know about what it does. And then it's up to you to know, how do I implement it? And that's just a matter of remembering. You will likely get an appendix where you have it, where you can see it as well. But just to make sure, it's like one line of code, so it's not too much to remember, or 2 lines of code altogether. So you just need to know that you create a timeline, add a keyframe to the timeline, and in the keyframe you add the interval, so in this case duration.millis, and then as a second parameter in the keyframe you add a lambda expression which calls some function. You don't need to know what that E is, right? You see E arrow some function. You don't need to know what that E does. All that you need to know is that in this case, every 500 milliseconds, some function will be called. Then the next important part is that you add the timeline.setCycleCount to timeline.indefinite. Those 2 lines you just need to remember. And then the timeline.play and the timeline.pause are quite straightforward. No questions on this part?
Well, There was a question about what the second parameter was, but I think you just said it.
Right. Okay, perfect. Then event handlers. Event handlers are tricky because you didn't have to implement this yourself, but essentially event handlers they are also some form of like listeners that listen to either key presses on the keyboard or mouse events essentially. So let's say that you have a pane, then you can say something like, and the pane is called root, then you can say root.setOnKeyPressed. You can also say something like setOnKeyReleased. There are a couple of things, but these I don't think that you need to know explicitly which one is which. And again, this is one of those cases, if we understand what your intention is, that's the most important part. So for example, if you say root.keyPressed, then it's fine as well. The same, anyway, so you can add event handlers to a pane, for example, and by saying root.setOnKeyPressed, then you get a Lambda expression in there again, with the input element being key or E or whatever, and then you call some function. Now here you can see that I actually pass the key into some function, and the reason for that is because that key actually holds information on the key event. So let's say that I press the letter S on my keyboard, then the fact that I press the letter S is in that key variable. So I can say, for example, like you can see in the comment that's below it, key.getCode to get the specific key that was pressed. What I would recommend, like this is like a lot of talking, what I would recommend for you to do is look at, for example, this question. This is an old exam question. I'm not going to go through it entirely. You can read it all by yourself, but in like very quickly, you just need a program that you can see at the bottom. Basically, if every time you click, then another ball gets added to the list, or it gets added to the string, and then the ball change color essentially. If you manage to create this, then I think you're very good to go for the exam. I think this covers a lot. I also put like an example solution. I didn't use binding in my example solution, but you can try to use binding in your example or in your solution. It's just a fun way to practice the Java, or I won't say fun, it's a way to practice the Java FX. And if you get this down, then you're pretty much good to go for the Java FX. No questions again? Cool. Okay, on to the last part of the presentation, concurrency. So concurrency, the most recent topics, normally Java applications or just programming applications in general, most of the time work sequentially. So they work one thing at a time, can finish it, then go on to the next. Concurrency allow you to do multiple things at the same time. So those things that are basically able to multitask are called threads. Those are the things that can work in parallel. However, when you work with threads, and that's also what you mostly see at the exam, what happens is if two threads are using the same object, you need to be very careful that they don't want to work with the object at exactly the same time. Essentially, you need to use synchronization to make sure that they can't change the object at the same time. And to give a real life example, let's say that I go to the bank and I want to deposit some money. Let's say that there's like 60 euros on my account and I want to deposit 10. Now let's say that my mom comes in at the exact same time and she wants to withdraw 20. We all know, okay, we have 60, we deposit 10, withdraw 20, we end up on 50. But if we do that at the exact same time, there is a chance that either my operation or her operation is basically ignored, which basically means that I deposit money and she withdraws money, but that the bank account only listens to one change, which means that it will either go to 70 or it will go to 40, but it won't go to 50. And that's why synchronization is very important. So a very basic thread example, this you've seen, you make sure that the class that you want to do or that needs to do the multitasking implements runnable. You get the run method, and then whatever is in that run method, it can happen at the same time. So let's say that I create 2 threads. In this case, I just make 2 threads that can count from 0 to 10, and I give both the threads a name. So one I named Jacques, the other one I named Peter, to pay reference to the teachers of this course. The output would be Jacques says 0, Peter says 0, and they just count simultaneously.
Should have changed it to Paul.
Yeah, Peter's the old teacher, for the people that don't know. Anyway, now into the synchronization part. And the synchronization part you've seen in the last 2 assignments, which is with the lock. So the teachers provided you with basically some recipe to follow if you want to do synchronization, which works, but I find it quite a confusing recipe myself, so I go for this one. This is my recipe. Just pick whichever one's more useful, but hopefully this will be a bit useful for you. But let's look at it step by step. First part is determine the shared object and give it a lock. We'll look at an example afterwards, by the way. With the shared object, ask yourself who has to wait for what. And that question essentially answers what the conditions are. Then implement the methods in the shared object class and make sure that the methods throw the exceptions and not catch them. This is a very important thing that I saw in the assignments all the time. Then determine and implement the runnable classes, so the classes that are running at the same time. And most of the time, the teachers want to see a thread.sleep and some system out or print in the run method. And the run method is where we catch the exceptions. Now, why do they want to see the sleep and the system out? Basically, most of the time you're creating some simulation, and then the thread.sleep is the waiting time for the simulation. So one of the students in the assignment with the trains and the taxis, he left a comment essentially saying, well, I didn't add the sleep because I think the reason was because the train already has to wait before it can drop off its passengers. Even though you think it's already waiting, just add the thread.sleep, right? If they ask you to basically have a short delay, just add it. It will cost you points if you don't. And then lastly, create and start the threads, preferably using an executor service with the future statement. Anyway, to look at this step by step, we're going to dive into an example. Imagine we have a restaurant with a buffet, and the guests at the restaurant can only grab food from the buffet when there's still food left. And we count the food here just as an integer. So we say there's 1 food, 2 foods, 3 foods, right? The kitchen can only add food to the buffet if there's less than 10 foods left. When the kitchen adds food, they add it until the buffet is full, which is a max of 30, and the guests grab a random number between 1 and 5. I see a question.
Why throw rather than catch exceptions?
Okay, the reason for that is you want to catch them runnable essentially in the run function. And the reason for that is because that gives you a lot more information in practice on where it went wrong, essentially. So if you throw it in the shared object, well, then you know that something went wrong, but you already knew that because your entire class crashes, but you don't know where it went wrong exactly. Now, if you throw it in the, or if you catch it in the run method, then you know exactly which thread is the one that messed up. So that's the reason. Okay, so back to my example. Determine the shared object and give it a lock. Well, the shared object is the buffet because there are multiple guests and 1 kitchen using that class. Also, in the exam, most of the time what I've seen is that there's a shared object that has basically 2 types operating with it, working with it. So for example, the taxi and train assignment was a perfect example where you had 1 train and multiple taxis. So determine the shared object, give it a lock. So the buffet, we give it a lock. Point scored. With the shared object, ask yourself who has to wait for what to determine the conditions. Well, in the buffet there are two instances where someone has to wait. The guests have to wait when there's no food left or when there's not enough food left for what they want to grab. And the kitchen has to wait with adding food to the buffet when there is more than 10 food or when there's at least 10 food left. So that gives us two conditions for the adding the food and for grabbing the food. Next part, implement the methods in the shared object class and make sure that the methods throw the exceptions and not catch them. So we have a function add, which basically is for the kitchen to add food to the buffet. We have a function grab that is for the guests to grab food from the buffet. These methods always have pretty much the same layout, where they start with a lock.lock and then they have a try finally, and in the try finally they unlock the lock again.
In the finally.
In the finally.
You said in the try finally.
Oh, sorry. In the finally they unlock it. Thank you, Maaike, for gracefully interrupting the presentation.
You're welcome.
So next step is to actually add the weighting. By the way, as you can see, I added private final ints for the threshold being for the kitchen and the capacity, by the way, also being for the kitchen. Make sure that you don't add the numbers directly in the while loop. The teachers most of the time find it prettier if you just add private final ints somewhere in the class and put the or store the integers in there. So I think last year we even had to deduct points if people didn't do that. So for the adding the food, while amount, which is the current amount of food, is bigger or equal than threshold, the we call add food wait, essentially saying that the kitchen needs to wait. On the other side, while the amount is lower than to grab, so when there's not enough food for that the person wants to grab, we say grab food dot await. And then after, when they are done waiting, so on the left hand side, if it makes it past the while loop, then we know that the amount is lower than the threshold. So we know at this point that the kitchen can add food to the buffet. So we say amount is equal to capacity, and we give a signal to all the people who are waiting, essentially saying, hey, we just added food, you probably don't have to wait anymore. On the right hand side, we say the amount equals amount minus to grab. So essentially we deduct the food that the guests want to grab, and we give a signal, we pass a signal to the kitchen or to the add food, basically saying, hey, we just grabbed some food, maybe you don't have to wait anymore. Speaking of that, it would actually be prettier on the right hand side if I made an if statement, basically saying if the food is lower than threshold, only then give a signal. But this works as well. So it doesn't really matter which one you go for. Then determine and implement the runnable classes. So in this case, the guests is one of the runnable classes. So we make it and we make sure that it implements runnable. Then we give it an ID. Most of the times the teachers want to see these classes have an ID. In this case, we're going to give it a random object, or so a random, literally a random object, to make sure that it can generate a random number. And most importantly, we're giving it an instance of the buffet. So we're giving it an instance of the shared class. And the buffet and the ID will be initialized in the constructor because they will come from outside. We will give them the buffet from outside. One thing that I've seen before as well is that people say private buffet is new buffet within the guest class. If you do that, you're essentially implying that every guest has their own buffet, which I would love if that were true, but unfortunately, generally that's not how buffets work most of the time. So we have the run method. And there we do the try catch. We can start with that because we know that we need to catch the exception here. In this case, I went for a while true. I think that the assignment will basically indicate what you need to do. And if it doesn't specifically say that you need to run for a specific amount of time, just add a while true. In practice, it's not the prettiest solution, but for the exam, I guess it's the safest option because it's most likely that the teachers want to see that. So what do the guests need to do? They need to get a random number for the amount of food that they want to grab. They want to actually grab that from the buffet. Then we add a print saying guest with its ID. So for example, guest 1 grabbed, and then the amount of food that he or she grabbed. And then we add a quick sleep. By the way, I added a print statement to my catch. You don't really have to do that. You can, you don't have to. Then the last part, create and start a thread, preferably using an executor service. So this solution that you see on the left-hand side is probably already good enough. So you need a main method where you create an executor service, an int number of guests, a buffet, because you need a buffet for both the kitchen and for the guests, and then make sure that you create all the threads in a for loop and not create them manually. And then you say exec, which is the executor service dot submit for every object that you create. You've seen this last week, so I'm going through it fairly quickly. Again, this is something that you pretty much just have to remember how this works. And then at the end, call the exec.shutdown. Yes, question?
In one of the assignments, we had to do an infinite loop, but the function had a return statement. So a while true, and there is an exception. How would we handle this nicely?
In practice, you don't, because that was just a very ugly solution. It's never ever the case, or it should never ever be the case, that you have an infinite loop that needs to be interrupted by some other class. That's basically just not how it works. But if you want to treat it nicely or handle it nicely, I guess it was the assignment from last week, right, with the cashiers and the supermarket. I think that was it. They called the cancel method on I think everything that was remaining in the...
Like all the cashiers were just cancelled.
Yeah, all the cashiers were cancelled. So that's the one way of doing it. That's the one way of basically interrupting a thread. But like I said, it's never a pretty way of doing it. And I don't think that you'll see it at the exam, that you have to do that at the exam. But now you know that if you need to do that, then just go for a cancel method. Yes.
What's the difference between submit and execute?
I think submit actually gives a return statement. So with the execute, you just say that you run it. But in the last assignment, you saw that we didn't use runnable, but that we used callable, because there was actually a return statement, right? Every thread returns something. I think with execute, you don't have a return statement. And with submit, you do have a return statement. Essentially, that basically means that right now I'm using submit, while I could have used execute.
Why do you use execute with shutdown now and not shutdown instead of shutdown now?
Didn't know there was a shutdown now, so that's why. But that being said, this is basically the easier way of doing it, of creating all the threads and doing the shutdown at the end. This is the more preferred way, which you also saw in last week's assignment. So to just go through it step by step, again, you create the executive service, you create the number of guests, you create the buffet, and then you create a list of futures. And a list of futures, it's always very hard to explain this conceptually, but basically, because threads will run to a certain point, at some point they'll have like an end value, right? In my case, I added a while true, so it's a kind of a bad example, but generally threads only run for a specific number of time, for a certain amount of time. And then after that amount of time, they're done, right? So in the end, they have some end value, some future value, so to speak. So we can create a list of futures and then basically add the submit. Now we have to use the submit. Now we can't use the execute, because execute wouldn't give like that return state. Those submits to the futures. And that basically means that once this thread is done, then it will have some return statement in the futures. You don't need to know what all of this means. I'm just trying to explain it for people who want to know. If you couldn't care less about what I'm saying, just make sure to remember this as the pretty way this as the less pretty way. But this is one way to basically handle threads running properly and threads shutting down at the end. I saw a question.
Why did you put the question mark in the future?
The reason for that is because we don't know what the future type, what the type will be, what the eventual return type will be. So, for example, in last week's assignment with the callable, I think the end product was an integer, but it might as well be a string, right? It might as well be a boolean. And the question mark essentially indicates that we don't know of what type it will be. So it's some sort of like generic, but then future essentially is a generic class. And now we're saying, hey, you are a generic class, so you're expecting me to say what your type will be, but I still don't know, so I'll pass in the question mark.
You don't know the exact setup of the exam, right?
No.
Okay.
I wish I did.
And but there is no return statement in the run, right?
Yeah.
What does it return in this case?
Okay, so yeah, that's why I said right now I went for a while true in the run, which is pretty much by this is a very bad example from my side. This would be better if the run would run for the run would run for like 10 times or something. So in this case, it's a very bad example. But that being said, the futures doesn't care if there's actually a return statement. But it does try in this f.get to essentially when there's no return statement, the f.get will basically be an indication of when the thread is actually finished. That's because I don't know if you remember this from the assignment from 2 weeks ago, but in the beginning, if you just implemented everything and you called all the functions, it was going to show the statistics of the train and the taxis. And what it did was it showed the statistics at the beginning, then it showed all the taxis running, and then at the end, it didn't show anything because the statistics were already at the beginning. Now the exec.shutdown that you see at the beginning here, or now you don't see because I accidentally put the hover over it. So the exec.shutdown that you see over here, normally would already be called right after we execute the threads, because that's what threads do. They multitask. So the program continues with the code that's after it. Now, because we're using the get method in that for loop that's between the exec.submit and the exec.shutdown, the exec.shutdown is not yet called because it goes through that for loop first. So again, this is all like a lot of theoretical stuff, and you don't need to know how this works exactly. The most important thing for you to know is that if you want to create a number of threads properly and do it in the prettiest way, this is the solution. If you want to go for an easier way, which is just less code, go for this way. Maybe it will change like 0.1 or 0.2 points at your exam. But it's just like, honestly, to understand this theoretically, you need to work with threads a little bit more to really get this down. So I don't expect you to understand it, or not that I'm thinking like badly of you, but I don't expect you to understand or want to understand this.
Okay, so is that an answer to, do you think we have to use the futures, or should we be fine without?
I think that's sort of like a question, or an answer to the question. I think you'll be fine with this solution. You'll be definitely fine with this way of writing it, and you'll get most of the points, if not all of the points. If you don't want to do it if you want to go all the way, go for this way, go for this method. Essentially, it just adds that for loop that's in the middle, right? With the list of that goes through the list of futures.
Okay, but is it likely that futures will be on the exam?
It's unlikely that they'll ask literally like use the future here, or they'll ask something about the futures. But it is very likely that you'll have a concurrency question, and that they'll ask you to create a number of threads and run them. Now, if they ask you to create a number of threads and run them, then you need to know that using the futures is one way of doing that.
I think last year we had futures, but we didn't have to write anything about the futures ourselves. We just had to like use them by implementing the call.
Yeah, it could be. But yes, what I would just recommend, they will ask you to start and run the threads. That's what they'll ask you most likely. They won't ask you do something with futures, I don't think. So what you need to know is basically this part or this part as a manner to call threads. And then about the theoretical background, you don't need to know too much. Yes, another question?
Okay, and in the first example, can you also replace submit with execute?
Sorry, come again?
In the first example, can you also replace submit with execute?
Yeah, absolutely.
Yeah, that was it.
Okay. Well, then I was going to leave some room for questions, but unfortunately I have to leave straight away. So I hope everything was